Hello everyone, welcome to my channel, and in this video we will going to talk about numerical analysis and design MCQs. So the first MCQ, here are 20 MCQs and in this video we'll going to cover it all. Okay, so the first MCQ is which of the following interpolation techniques is used to find the values of a function at points lying outside the known data points. So the answer is C, that is Newton dividend difference interpolation. And what is dividend interpolation? Here we can see Newton dividend difference interpolation formula is an interpolation technique used when the intervals difference is not same for all sequence of values. So here is the formula for Newton dividend difference interpolation. Now the second question is which of the following is not a disadvantage of Newton's forward interpolation. It's which of the following is not a disadvantage, means here we have to find the advantage of Newton's forward interpolation. Okay, so here the option will be D, that is it is computationally intensive. Okay, it is computationally intensive. Yeah. Now the third question is which of the following interpolation technique is used to find the values of a function at points lying before the known data points. Now here the known data points you have to see, and its answer will be going to B. Okay, Newton's backward interpolation. Because here we can see Newton's backward interpolation is a polynomial interpolation technique that is similar to Newton's forward interpolation but works in the opposite direction. It is used to find the values of function at a point before the known data points. Okay, before the known data points. Then they like Newton's forward interpolation. It also requires equally spaced data points, and the formula for backward interpolation, Newton's backward interpolation, is this. So this sign is called nabla here. This is called nabla. Okay. Now the question fourth. Which of the following interpolation technique uses a polynomial of degree n-1 to interpolate n data points? So its answer will be D, Lagrange interpolation. Okay. Now what it is? Lagrange interpolation. Lagrange interpolation is a polynomial interpolation technique that uses single polynomial of degree n-1 to fit n data points. The polynomial is constructed in such a way that it passes through all the given data points. The Lagrange polynomial can be written as, so if you are having 2 points with coordinates x1, y1 and x2, y2, the Lagrange interpolation will be this one, y2 minus y1. This is the divide sign, x2 minus x1 into x minus x1. Okay. Now here we come to question 5. Which of the following is not a disadvantage of Newton backward interpolation? So it asking for which of the following is not a disadvantage, means here we have to find the advantage. Okay. So in the fifth question the answer C is correct, which is it cannot be used for Lagrange value of n. Okay, it cannot be used for Lagrange value of n, and here are some advantages and disadvantages of this. It is useful when the data points are equally spaced and the value of x to be interpolated lies near the end of the table. Second advantage is it requires less computational efforts compared to Newton's forward interpolation method. Now disadvantages are here. it cannot be used for large values of n when the degree of the interpolation polynomial becomes very large. It is sensitive to errors in the data points. Now the sixth is, now here the sixth, which of the following interpolation techniques is used to find the values of a function at points lying between the known data points? Okay, so this is very easy. The answer is D, Lagrange interpolation, as we already have studied, as I already told you about that. So yeah, it's Lagrange interpolation. Yep. Now the seventh question, which of the following is the correct formula for Newton's dividend difference interpolation? So we have already talked about it. So what is the seventh question answer from the A, B and C, D? That is the A option. Okay, that is fx0 plus fx0 comma x1 plus fx0 comma x1 comma x2 and like dot. Now in 8th question, coming toward the 8th question is here. Yeah, which of the following is the correct formula for the first divided difference in the Newton dividend difference interpolation? So it is fxi minus 1 divided by xiv. Already seen it. Okay, so here which option you can choose from here? It is D option from all these options. Okay, now coming towards the 9th question, what is the basic difference between Newton's forward and backward interpolation method? So what is the basic difference between Newton forward and backward interpolation? We have already seen it. Okay, Newton forward and backward. So it is the A option. Newton's forward interpolation uses forward differences, whereas backward interpolation uses backward differences. Very easy, right? So this is the A option. So now come towards the 10th question. In Newton's dividend difference formula, what is the purpose of using higher order differences? So in Newton's dividend difference formula, we have seen the dividend difference formula of Newton. What is the purpose of using higher order differences? So its answer will be A, that is to increase the accuracy of the interpolation. So this is the answer, to increase the accuracy of the interpolation. Now coming towards the 11th question, which of the following interpolation method is not based on polynomial approximation? Okay, so the answer of this, which of the following interpolation method is not based on the polynomial approximation? So its answer is D, that is dividend difference interpolation. Okay, dividend difference interpolation. 12th, what is the difference between Newton's dividend difference interpolation and Lagrange's interpolation? C1 is correct. Okay, not none of the above. C1 is correct. Now the 13th question, which of the following interpolation method is more suitable for unevenly spaced data points? It's Lagrange interpolation, the D option. Okay, now coming towards the 14th question, which of the following interpolation method is known as the method of finite differences? So 14th answer is C, dividend difference interpolation. So here the option is C. Now the 15th question, what is the order of the polynomial used in Newton's forward interpolation? So what is the order? We have already seen it before. It's B, n minus 1. Okay, in Newton's forward interpolation, what is the order? It's n minus 1. Which of the following interpolation method uses the concept of interpolation error? It's Newton forward interpolation? No. Newton backward? No. It's Lagrange interpolation. Okay, it's Lagrange interpolation. Now, which of the following interpolation methods can be used to interpolate functions with complex values? Newton's forward interpolation? No. Newton's backward? No. Divided? No. Lagrange interpolation. Okay, again Lagrange interpolation. 18th question. What is the drawback of using higher order differences in Newton's divide and difference interpolation? So it is higher computational. Yeah, here the answer is on the A only. So we have to take the A. Higher computational complexity. Coming towards the 19th question, what is the main difference between Newton-Cotes formulas and Gaussian quadrant formula for numerical integration? Now here, what is Newton-Cotes formula? Now Newton-Cotes formula, numerical integration method that use equally spaced points within an interval to approximate the definite integral of a function. Okay, the formula depends on the number of points used and the order of the formula. The weight for the Newton-Cotes formula up to the order are commonly used in the numerical analysis. Okay, Gaussian's quadrature formula are the numerical integration methods that use specific nodes and ways to approximate the integral of the function over a finite interval. So what the option for the 19th question here will be, Newton-Cotes formulas are equidistant points, whereas Gaussian quadrant formulas are non-equidistant points. Yeah, so the option is A only. Okay, so the option is A only. Now coming towards the last question of this video, which of the following is an example of a Newton-Cotes formula for numerical integration? It is both A and C. Okay, so this is the end of the video. Thank you very much.